Hello, everyone, and thank you for joining us for the Observability of the Open Source Way session. My name is Mark Sheney. I am an AWS service owner and principal product manager leading the strategy and releases for some of our AWS observability services. I've had the pleasure of being with AWS for over 3 years and bring over 12 years of product and engineering experience in the monitoring and observability space. I am joined today by Amaya, a principal solutions architect specialized in observability. Amaya and our AWS team of solutions architect are on the front lines talking to customers and solutioning tough problems like a cross-account hybrid metric collection, and most importantly, making sure that we share these patterns and getting started experiences for monitoring and observability with our customers by sharing blogs, workshops, and videos. So I encourage you all to look at these resources to help you in your observability journey. Our session will walk you through how AWS has simplified how you can use popular open source services such as Prometheus and Grafana as part of your observability journey to detect, investigate, and remediate issues impacting your most critical workloads. We will also walk you through an end-to-end demo of how easy it is to set up and use these services for monitoring and observing workloads running anywhere. Operators have been monitoring systems availability and performance for years by watching gauges, charts of metrics, and looking at triggering alerts over time. Monitoring is all about looking at what you know. And is important or could go wrong. The anticipated. The availability, transactions per second, error, latency, all the types of APIs that you'd want to be able to monitor and alert yourselves on when you're having issues. Observability allows you to actively disseminate information from your entire systems, finding the unexpected. It is the ability of a system to be observed by gathering telemetry to allow our builders and operators to efficiently detect, investigate, and remediate issues faster. Detection is the known availability and performance from static alarms that engineers set up to proactively or reactively notify them of problems. Investigation is what typically takes the majority of the time to find isolated or systemic issues across all your data sources. Remediation is how we mitigate and resolve customers' impact and document and automate, when possible, the operational procedures for the resolution. The collection and unification of 3 foundational sources of telemetry typically come from metrics, the measurements over time, the logs, the unstructured data, right, where you would use to be able to do the forensic on it, and the traces, the cascading effect and impact upstream or downstream of transactional workflows that impact your customer experience, which are all the output of their monitored environment, such as containers. These sources of information help create a cohesive way for engineers to isolate critical events that impact containerized applications and microservices running anywhere. AWS provides choices in monitoring and observability services that you can use to collect, store, investigate, and alarm on data from your infrastructure and containerized and serverless applications running on AWS and hybrid environments. Together, these services complement each other by providing insights and analytics using predefined instrumentation and visualizations. We are going to talk about 3 open source services that you can use to monitor and observe your telemetry. First, we'll talk about how Amazon Managed Service for Prometheus can be used as a highly available, secure, and managed monitoring and alerting service for any operational metrics. Second, we will talk about our journey with AWS Distro for OpenTelemetry as the portable telemetry collection and traces and metrics. And last, we'll highlight the importance of using Amazon Managed Grafana as a scalable, secure, and highly available rich data visualization for your operational metrics, logs, and traces. Before we dive into these services, let me take a step back and tell you why managed AWS services are important to our customers. Security is our top priority. We continuously patch for security vulnerabilities and natively integrate with AWS security services such as Identity Access Management, IAM, to simplify access and identity controls. We comply with General Data Protection Regulation, GDPR, to protect your rights to privacy and the protection of your data. You can also rest assured that all data in transit and at rest is encrypted. Our open source services can be trusted to monitor your production workloads. We operate the underlying infrastructure to remove the undifferentiated heavy lifting to help you focus on what matters most to your organization. It's to innovate, of course, and operate secure and reliable services for your customers. We will continue to make our services easier to use by seamlessly integrating with other AWS services. Examples of these integrations include making sure your traffic stays on the AWS network with Private Link and auditing access to these services to meet your compliance needs by integrating with CloudTrails. Last, and certainly an important reason why I started this journey, is to contribute back to open source through design contributions, code reviews, bug fixing, and contributing new features. It's hard to believe that a year has already passed since Werner Vogel announced the preview release, and we showcased the benefits that our customers would gain from our open source services at reInvent 2020. I'm very excited to share the next accomplishments in our open source journey that have led us to the general availability for these services. Prometheus enables real-time alerting and monitoring optimized for high cardinality and high volume time series metrics. Common use cases are currently used by customers such as Twilio, Bridgewater, Curve, Fanatics, and TF1 include unified container monitoring, troubleshooting and root cause analysis, workload and application metrics monitoring, and high cardinality metrics monitoring. This fully managed service automatically scales as your ingestion, query, and alerting needs grow, handling millions of unique time series metrics from large container deployments running on AWS and hybrid environments, while maintaining consistent query response times. This fully managed, the Amazon Managed Service for Prometheus is fully compatible with Prometheus Data Model and PromQL, Prometheus Query Language, helping you create powerful, flexible, and simple queries to find isolated or systemic problems across all your operational metrics. There's no upfront cost for the service. You pay for the metric samples you ingest and store, and queries you use for monitoring and alerting. Let me tell you a little bit more about what's new as part of our general availability. Our path to GA included several new features that our customers asked for, including a recent price reduction for samples ingested, which by over 55%. Over the last year, we built, operated, and optimized the Prometheus fully managed service without compromising security or high availability. Through this journey, we learned a lot about how to run and optimize a service. Being customer obsessed, it is important for us to understand both how customers are using and want to use Prometheus. You told us you wanted to be able to collect metrics at intervals as smaller than 15 seconds, and you wanted us to be able to send any volumes of metrics from thousands to tens of millions to monitor and observe your critical infrastructure and application availability and performance. The pricing reduction addressed this feedback and also passes along savings we achieved with optimizations in operating the service. Support for Prometheus compatible Alert Manager and Ruler was the #1 feature you requested. You can now use a Prometheus compatible Alert Manager configuration to deduplicate, group, and route alerts notification to Amazon Simple Notification Service, SNS. You can also define Prometheus compatible recording and alerting rules. Recording rules allow you to pre-compute frequently needed or computationally expensive PromQL queries and save the results as new time series. An example of this could be pre-computing CPU or memory performance across all running pods by namespace. Alerting rules allow you to define alert conditions using PromQL that then trigger notifications via SNS that can be sent by email, SMS, mobile push, or to other third-party partner services via integrations with Lambda. Check out the documentation and blogs to learn more. Automated provisioning of workspace, rules, and alert manager configurations are now supported using CloudFormation and Cloud Development Kit, CDK. A workspace is a new term that we've introduced as part of this Prometheus service that represents a logical and isolated space dedicated to the ingestion, the storage, and the alerting and querying of the metrics from one or many Prometheus servers. You can create as many Prometheus workspaces per regions that you need. You can also tag your Amazon Managed Service for Prometheus workspaces to help manage, identify, organize, filter, and control access to them. As part of the GA release that we announced in September, we've added 4 new regions. We are planning to support the remaining regions next year. We rely on product feature requests, PFRs, to help us prioritize features and regions we will be targeting next. Please let your account teams know or contact us directly to help us prioritize new features. Let me walk you through our setup. The following diagram provides an overview of what makes the end-to-end solution. There's really 3 parts of this: the collection, the actual workspace that contains all your metrics that we're storing, and then the ability to define these rules in Alert Manager, and then the querying. You can reuse your existing Prometheus server configurations or AWS distro for OpenTelemetry, which I'll talk about next, or any other compatible collectors that support the Prometheus remote write features to securely send any volume of metrics securely to the Prometheus workspace, either via the public internet or via a VPC endpoint. Data can then securely be queried using Prometheus-compatible APIs, including those supported by the Prometheus Data Source plugin available in Grafana. So OpenTelemetry is a method of collection. It's an open source, it's a cloud-native computing foundation open source project that provides a set of APIs, SDKs, and agents to enable developers to instrument their application and send correlated traces and metrics to a destination of their choice. It has been created from the 2 mergers of 2 open source projects, OpenTracing, which aim to provide distributed tracing support for, and OpenCensus aim to provide support for metrics and traces. OpenTelemetry today has SDKs in 11 plus languages and auto instrumentation agents in languages like Java. Several of our AWS partners are contributing to this project. Over a year ago, we announced AWS distro for OpenTelemetry. This is an open source distribution of OpenTelemetry from AWS. All the enhancements that AWS will be contributing to OTel will be done upstream. This is not a fork of the project, but rather a distribution downstream of OpenTelemetry that we support. Our goal is to provide a production-ready distro with predictable performance and component backed by AWS support. AWS distro for OpenTelemetry announced GA of tracing support this September 23rd. You can now use the secure distribution of the OpenTelemetry open source project supported by AWS to instrument your applications and send traces to distributed tracing services such as X-Ray and OpenSearch. You can instrument your applications running on EC2, ECS, EKS, and Lambda for programming languages such as Java, Python, Go, and Node.js, and .NET, using OpenTelemetry SDK with auto instrumentation available for Java, Python, and applications. We're continuing to work closely with the open source community on the stability and general availability of metrics. We are also leading the special interest group to support the discovery and collection of Prometheus metrics as a receiver and the ability to send these metrics to Prometheus-compatible remote write APIs, such as services like Amazon Managed Service for Prometheus. So what's next? How best to visualize and interact with all these sources of observability data? Well, Grafana, of course. Grafana is the interactive visualization tool of choice used by the majority of engineers that use Prometheus. Grafana is also used to visualize, correlate, and analyze other observability data sources for monitoring and troubleshooting infrastructure and application health and performance. Common use cases include unified observability, container monitoring, IoT monitoring, and troubleshoot operational issues collaboratively. Amazon Managed Grafana is a highly available service, available across multiple availability zones. The service automatically scales based on the number of teams and end users visualizing data and alerts created to monitor any data sources configured. As an enterprise-ready security service, the service is integrated with AWS SSO, and allowing you to use your own identity provider for authenticating and authorizing end users to access and manage dashboards, alerts, and teams. Role-based access control gives you fine-grained access control configurable by end users, including predefined administrator, editor, and viewer roles. All configuration data is also encrypted, such as dashboards and alert definitions. Our path to GA support for Grafana Enterprise Data Source that can easily be upgraded via AWS Marketplace subscription for partner solutions such as AppDynamics, Datadog, Dynatrace, MongoDB, New Relic, Snowflake, VMware Tanzu Observability by Wavefront, and more. We give you a pay-as-you-go service based on the active monthly viewers and editors that log in to the service. Grafana natively integrates with AWS services to discover and securely access services you want to set up as data sources, such as CloudWatch and Prometheus, across all your AWS accounts, using a very simple click-through process. Other native AWS services included are Amazon Open Source Service, IoT Sitewise, TimeStream, and Xray. Third-party partner solutions such as InfluxDB and Graphite, as well as cloud provider integrations, are also supported. All right, so let's talk about what we also included as part of general availability. So we added support for one of the most requested features, which is security assertion markup language, so SAML 2.0. It enables single sign-on for Amazon Managed Grafana workspaces. Using SAML, you can integrate directly with your identity providers and enable users to log into a workspace with your existing username and password. To simplify setting up SAML, the service also integrates with the dedicated SAML applications built by CyberArk, Okta, OneLogin, Ping Identity, and Azure AD, which you can discover and configure directly from your IDP's application galleries. We've added support for Grafana API keys and the Terraform Grafana provider to enable management. So this is looking at the creation, the update, or the deletion of your Grafana resources, including dashboards and data sources and all other types of data sources. CloudTrail Integrations provides the IT compliance needs to track the audit changes with an expanded set of CloudTrail logs, such as when dashboards are deleted, data source permissions are changed, and more. We added support for 9 new data sources, and the service is now available in 10 regions. We now support the latest features in Grafana version 8.0, such as library panels that you can build once and reuse on multiple dashboards, also including a Prometheus metrics browser to quickly find and query metrics, new state timelines, and status history visualization, and much more. What I'd like to do is hand it over to Amaya to give you an end-to-end demo of our observability services, some of these open source services that we talked about today.
Thanks, Mark. Well, quickly introducing myself again. My name is Amaya Kumar Jagannathan. I'm a Principal Specialist Solution Architect focusing on observability. And next, let's take a look at a full-featured observability demo focusing on Amazon Managed Service for Prometheus, Amazon Managed Grafana, and OpenTelemetry.
I'm on the Amazon Managed Service for Prometheus homepage, and the first step is to create a workspace. You can create a workspace from the console by simply clicking on the create button here and giving it a name, something like demo workspace, for example, and you would be able to create a workspace by simply clicking the create workspace button. In just a few seconds you will have the workspace created. There you go, it is already active. But there are also other ways to create workspaces using either CloudFormation or using AWS CLI. So here I have a CloudFormation YAML file that I'm going to use to create the workspace. So the name of the workspace that I'm going to give is observability-workshop, and I'm adding a couple of tags, the resource tag for this. So for this workspace. So to run this to use this to create the workspace, all I have to do is run the command something like this. Let's go to the folder, clear this out, and I'm going to I'm going to paste this command here, AWS CloudFormation create tag, and then now it's getting created. So let's go here and go to the workspaces screen, and we should be able to see the workspace. There you go. So here we have the observability workshop workspace that I created through CloudFormation, and this is the one that I created using the console. In addition to using CloudFormation to create workspaces, you can also use this API reference documentation to see what other management operations that you can do. Here you can see a list of operations that you can perform on the Prometheus workspace, and you can also see that we have Prometheus compatible APIs here that you can use to get the details of your the data in the workspace. For example, you can get the alert manager status, and you can get the labels, you can get series, and so on. There are lots of things that you can actually do with using APIs since we launched the service in GA. Now let's go back to the Cloud9 console that we used to create the workspace, and go to the next step. So what we're going to do is we're going to set up monitoring for an EKS cluster. So I have an EKS cluster here, but I have some workloads deployed. You can see that I have some pods, some application pods, and I have other than that, I don't have too many things here going on. Just the application pods that are deployed in the default namespace, and that's pretty much it. So what I'm going to do is I'm going to collect infrastructure metrics from this cluster, and also my application itself is exposing metrics in Prometheus format. So I am going to extract or scrape metrics from the application endpoint, and also ingest that into the workspace as well. So this is an application that is written using ASP.NET Core. It exposes some custom application metrics, and also it exposes some runtime specific metrics, the .NET runtime specific metrics. All right, so now what I'm going to do is I'm going to follow instructions from the observability workshop. So this is a public workshop that you have access to, and everything that I'm showing here you can also do it by yourself. So here under the Amazon Managed Service for Prometheus section, I have ingest metrics from Amazon EKS section. So in this we have all the instructions that we need. So first, installing Helm, and we have Helm installed already. I have that taken care of, so we don't need to worry about that. And now what I'm going to do is I'm going to add the Prometheus. I'm going to install Prometheus using the public Prometheus community Helm chart. So I'm going to do that, and also add the cube state metrics so I can get them infrastructure metrics as well. So I'm going to copy those commands and just run it here. So you can see that the Prometheus community has been added, and cube state metrics have been added, and everything is successful. Happy helming. Okay, perfect. So that's all good to go. Now what I need to do is I need to set up IRSA, or IAM roles for service account. So I already have the IAM roles, the IRSA, the basics for IRSA setup. What I've set up is I have set up the IAM role that with the trust provider, with the trust relationship set up with the OIDC provider. So if I go to IAM, I'm in roles, and AMP, this is the IAM role that I'll be using. And here, if you go here, I've created the trust relationship with the service account, and that can actually use the STS assume role with identity action using this role. So you can see the permissions. I only have the ingest policy, so that is the only thing that I need, and this is a managed policy that you can use. It simply allows you to ingest metrics into Amazon Managed Service for Prometheus. All right, so now I have that. So what I'm going to do is I'm going to go back here. So I don't need that, but I still need to create the namespace called Prometheus. I'm going to copy that, and I'm going to copy here and paste that command. I'm going to say OK, and I'm going to right click and paste it once again. If that doesn't work, I'll Command V. All right, so I'm going to do that, and so the Prometheus namespace already exists. Let's see if the namespace exists. Oh yeah, so the Prometheus namespace already exists, so I didn't have to create that either. And now let's go, so we can skip this too, so we already have that. So now what we need to do is we still need to we have to deploy the Prometheus server to collect metrics. So what I'm going to do here is I'm basically going to set the service account annotation to the pod that is going to assume that's going to basically make the calls to the Amazon Managed Service for Prometheus workspace to send the metrics to the destination. So this is just a simple Helm install command, and you can see here that I'm getting the Prometheus role on, and which is basically the one that I showed you earlier, and it is going to get the workspace ID, which has the name called Observability Workshop, and we have a workshop or the workspace with that name, so that's taken care of too. And I'm going to basically make use of these things. So I'm going to do the service account annotation. I'm going to do the remote write. So this is one of the most important things. So you have to have the remote write configured. So your Prometheus server, once it scrapes the metrics, it can remote write those metrics into the remote destination, which is the Amazon Managed Service or Prometheus endpoint. And the Prometheus server uses SigV4 protocol. So the remote write APIs and the query APIs, they're all protected by SigV4. So when you make calls to those endpoints, you have to use SigV4 authentication. So the Prometheus server uses the Go SDK, so it will use the Go SDK credential provider chain. So one of the ways that Go SDK can make use of is if you have IRC, it'll take that role from there. You can also manually configure the credentials as well if you want, but this is one of the best ways to do it. Just leave it to the IAM roles configured in the underlying compute environment. So what I'm going to do is I'm going to copy this and I'm going to go here. I'm going to Command V, basically paste that. Yeah, that's going to fail because I'm actually not in the folder that I'm supposed to be. So I'm going to go to the folder where I need to be. So here I'm inside this folder. The reason is that I have those the files that are required available under the resources folder here. So all this content that I'm showing here is actually in a public GitHub repo called One Observability Demo. This is part of the workshop itself. So you can actually go here and find all the files here. So these are some of the files that we'll be using. In fact, the file that we'll specifically be using is this ingest override values. So so what we're doing is we're overriding some of the values in the values.yaml that comes as default in the Prometheus chart. So the things that we're doing is like I showed you before, so the service account, and we are configuring the remote write, and there are certain things that we're disabling, for example alert manager and push gateway and those kind of things. We are disabling that, so we don't need those things. All right, so that's what we're doing. So let's go back to here, and let me paste again, and this should successfully execute. Okay, there you go. So now we have the Prometheus server up and running, and we can go see Prometheus. We can keep a watch on that, and you can see that this is currently this part is deployed. The containers are currently getting created. The 0, 1. Once it becomes 2 by 2, you have both the containers there. So the Prometheus server actually has two containers, and the one is the actual Prometheus server. The other one is the config reloader that basically keeps an eye on the configuration and reloads the configuration. So that's what it's used for. So the Helm comes as a package along with it. So so as a summary, what we have here is we have the cube state metrics deployed. We have node exporter because I have two nodes in this cluster. So there is the daemon sets, there are two nodes, and I have Prometheus server that is deployed as a stateful set, and I have one copy of that Prometheus server running in my environment. So there you go. So now I have everything up and running. So I'm going to Command C it. I'm getting out of it, so I'm not watching it anymore because I have my servers running. So unless they're crashing, they should be still running. So they're still running, so there's no problem. I do not see any issues here. So now what is happening is now already my Prometheus server is scraping metrics, and it is remote writing the metrics into the endpoint. Well, we can also see what it is scraping, so we can simply go and let me do the port forward command. So there you go. So there's this port forward command. So what I can do is I can actually port forward into that Prometheus pod. So here I'm port forwarding into this port 8080. Anytime you do the port 8080 put forward into in the Cloud9 environment, you're able to preview the running application. So that's what I'm doing here. And let me take it outside into new tab. There you go. This is not to be confused with the Prometheus workspace, but this is actually the Prometheus server that is running in my local environment. I am here, and I should be able to see the metrics that are currently being scraped. So here I have all these different types of metrics, and some of them are custom application metrics. So you can see this pet site, I told you about them. So this about that application exposing metrics. So these are some of the metrics that it's exposing, and you can see that they are just they just started coming out. And I have this application running behind, and there's a traffic generator that is hitting the application all the time, so it is creating many metrics like this. And okay, so that's that. And what I wanted to show is the configuration. So if I go to the configuration, here I have the Prometheus script configuration, lots of jobs with Kubernetes API servers and all that, but all the way down you will see that I have the remote write configuration. So the remote write is actually writing into the remote write URL, which is basically the same as the remote write URL that in our workload. So you can see there in our workspace. So this is the same remote write URL that is that's here. So that's here, and we have the Zigbee for UC East 1. So this is basically the same region. So that's what it is about. And so there you go. So now that we have this, we should be able to see the metrics in the Prometheus workspace. But before we get there, I also want to show that there is another way to collect metrics from this environment. The other way to collect metrics from your workloads is to use the AWS distro for OpenTelemetry Collector. So the instructions for that is also straightforward. So just before I get there, super quick refresher on AWS distro for OpenTelemetry Collector. The OpenTelemetry Collector is a single collector that can be used to collect metrics and traces. So today it does support Prometheus metrics, although it is not final. But the trace collection is final, so you can use it to collect traces. But ultimately, the goal is for the OpenTelemetry Collector is to be that one collector to collect all different signals from your environment, logs, metrics, and traces. The AWS distro for OpenTelemetry Collector is a downstream distribution of the collector, which allows you to do that. So in this example, I have created a pipeline here in my pipeline. So I'm using the Prometheus receiver because my metrics are in Prometheus format, and I'm sending them to the AWS Prometheus Remote Write endpoints through the Prometheus Remote Write exporter component. So this is my pipeline. It is receiving in Prometheus format and exporting into Prometheus. And you can also use the AWS distro for OpenTelemetry Collector to send those metrics to CloudWatch as well if you want to. All right. So the way I would deploy that is what I'm going to do is I'm going to actually deploy this also in the same under the same namespace. And there's just one file that I want to show you. So this is the I'm going to deploy it as a daemon set, and here the file for that is here as well. So let me go back to here, and not this. Go back to this and show here, and this is the file that I'm using. So here you can see that I have the receiver as Prometheus, and I have the exporter as AWS Prometheus Remote Write. So this is the endpoint, the Remote Write URL, and I'm going to just simply configure the region to which I'm going to send it to. So those are the two things that you really need to worry about. And also I only have one job, and this is only going to look for endpoints, or service endpoints, or Kubernetes service endpoints. So I minimized the number of metrics that I'd be looking at. So in this case, it is only going to scrape metrics from Kubernetes services that expose metrics in Prometheus format, and also are configured to be scraped from their endpoints. So the application that I deployed in this cluster is configured to be scraped, so the ADOT collector can scrape metrics from their endpoint. So I'm going to go here, and I'm basically going to copy this whole thing. So this command essentially downloads, copies this, and sets the account ID, region, and all that, and simply applies it as daemon. So that's all it does. So here I'm going to go here, and since I copied, I'm going to do a command V. Now I copied it, and there you go. So this is deployed as well. So now I can actually go see get pods, Prometheus. If I see here, I should also see the OpenTelemetry collector. There you go. So these are being deployed as daemon sets, and as I said before, there are two nodes here, so you're seeing two collectors, so both should be up and running. Yeah, so both are up and running, they're healthy, it seems, and both ADOT collectors should also be scraping metrics. But just one more point here. So to differentiate what metrics is coming from what, I have added this piece, a namespace called ADOT. So this actually makes the metrics be the string ADOT to be prefixed onto the metric names that are collected from the ADOT collector. So to identify what metrics is collected from what. This is just a just one way of identifying metrics collected from different collectors here in this particular setup. All right, so now we have all the metrics in our Prometheus workspace. Now next what we need to do is we're going to go and provision a Grafana workspace, and we're going to query the Prometheus metrics and see how Grafana can be used to monitor and all that. All right, before we create the Grafana workspace, let's take a look at how we can create the alerting rules and recording rules in Amazon Managed Service for Prometheus. If you remember before, I mentioned about having the alert manager disabled in the local environment. So which basically means that customers do not have to run alert manager themselves, because you can actually make use of the Amazon Managed Service for Prometheus service for your alerting needs as well. So here, if you see here, I have a couple of files. I have a rules.yaml file, and this rules.yaml file, in this rules.yaml file, I have two recording rules and two alerting rules, and I'm creating a new metric series, based on a PromQL expression, and I also have an alert, or actually a couple of alerts that are getting triggered based on the values of that newly created metric series. So here, I just want the alerts to be triggered, so I'm triggering alerts whether the pets waiting for adoption number goes less than 10 or greater than 10, so right away, so we can see the alerts. So that's a really simple alerting rule there, and I also want to show you the alert manager configuration. So today we support Amazon SNS as the destination for you to send notifications from your Amazon Managed Service for Prometheus, and you can obviously use SNS's integration with other services such as AWS Lambda to make use of that functionality and trigger your dispatch your alert notifications to other services as well, like Slack and PagerDuty and so on. So that's a really simple alert manager configurations here. So one, you can obviously use the use CloudFormation or CLI to create these alerting and recording rules, but I want to show how you can do that really easily in the console as well. So if you go to Rules Management tab on the workspace page in the Amazon Managed Service for Prometheus service, and you can go and click on Add Namespace and click on Choose File, and I'm going to simply choose this new rules.file, and it actually validates the rule when you upload, and if there's an error, it would throw that error right away and tell you if the file is not valid. And while it's creating, I can also go ahead and create the alert manager definition as well. So I'm going to choose a file for that, and I'm going to upload the alert manager.yaml file. So here, when I'm uploading, one thing that you need to remember is that the ARN that I showed here, the SNS ARN, the SNS topic must exist beforehand. It would validate that also and tell you if that doesn't exist. So you wouldn't be when you create the alert definition, you should you have a valid SNS topic created. All right, so now let's, in the next section, we are going to go to the Amazon managed Grafana service, create a workspace and configure authentication for the Grafana login or account, and query the data from the Amazon managed service for Prometheus workspace. So this is the Amazon managed Grafana service homepage, and we're going to create a workspace by clicking on create workspace button here. We can either do that, or we can also use the create the APIs to create workspace, and you can see that it's a pretty straightforward. You can use the AWS CLI or any other mechanism to make post calls to this API endpoints by supplying the details in JSON format, and you should be good to go. But for this purposes, we're going to use the console to create the workspace. So here we're going to maybe just say demo workspace, demo workspace, and I'm going to click on next. And there are two authentication methods. So one is using the AWS single sign-on. So this is this option existed even before we went GA, but at GA we launched a new option for to provision user access to the Grafana workspace, which is the SAML option, the security assertion markup language option. So here, using this, you can actually use any third-party identity provider that supports SAML 2.0 to provide access to your Grafana environment. So when we went GA, we launched with several identity provider partners like OneLogin, Okta, CyberArk, Ping Identity, and Azure AD. You can check our blog post that gets into the details of all of that. But for this purpose, here I'm going to actually use a SAML option, and I'm going to use one of the partner identity providers. But the idea, the point here is that there are two ways for you to authenticate users. And for permission type, you can, of the workspace itself, you can either use the service managed IAM roles or customer managed IAM roles. I'm going to choose service managed for simplicity's sake. And the Amazon managed Grafana can actually talk to data sources from the same AWS account from different regions, or it can also talk to different AWS accounts in your AWS organizations. To do that, you will have to simply provide the OUID here, and we will take care of provisioning the IAM roles and policies using CloudFormation stack sets that the Grafana workspace will assume to talk to the account that you want to talk to. So here, I'm going to select current account. And you can select all the data sources that you're interested in. Selecting all the data sources basically means that the roles, the role that gets created for this workspace will have all these permissions added, or the policies attached, necessary policies attached. And from in addition to these data sources, there are multiple other data sources as well that are provisioned out of the box, which we will see later in the next section. But from AWS perspective, this is the list, and the list also continues to grow. So from a notification perspective from AWS, Amazon SNS is the destination that we support. And from within Grafana, you can talk to other data sources as well, which is also something that you can take a look at. I'm going to click on next, and that's pretty much it. When review and create, if I click on create workspace, it will go and create the workspace. It takes a minute or so. So what I'll do is I'll cancel this, and I'll go and show a workspace that I already created. I did exactly the same thing that I just showed, and this workspace is already ready. Let's click on the SAML configuration button here, and inside you can see that I have the metadata URL configured to OneLogin. And if I go to the OneLogin, I've logged into OneLogin administration screen. You can see that Amazon Managed Grafana is already here. So if you click on that, under SSO section, that's gonna come up real quick. So here, SSO section, you can see that this issuer URL, this SAML metadata URL. So that is the URL that I have configured here. And you can also download the SAML metadata. Many identity providers allow you to do that. You can download the metadata, and you can upload that as well as another option. So for now, I'm going to use the URL option here, but I have already configured the URL. And here, this allows me to specify what users that are logging in will have admin access. So any user that is logging in with the SAML assertion admin role with value set as SDE will have admin access when they log into Grafana. So that you can actually see if you go to users. I'm the only user here. You can actually see that this admin role attribute is being passed in the SAML assertion, and that is what with the value of SDE, and that is what I will that's what Grafana will look for. And if it finds it, it will allow it'll it'll consider the user as an administrator. And there's additional options here as well, so you can have much more granular control. So you can have specific organizations from your identity provider that can have access to Grafana and stuff like that. You can control, you can have much more granular access. So for now, I've not made any changes, so I'm going to cancel this and leave it as it is. If I click on this button, this should technically take me to one login, because I have a log me into Grafana directly without any credentials. But what I'm going to do is I'm going to open in a new container tab, so I can show how the login works. So here, this is the login screen. Because I have SAML, it says sign in SAML with SAML. I'm clicking on that button. This is going to show me the one login screen. It's saying connecting to Amazon Managed Grafana, and here I'm providing the user ID and the password. We're going to click on continue. This should log me in and log me in as an administrator. So there you go. So I am now logged in, and I am logged in as an administrator. So the reason why I know that is because I have all these features that allow me to create dashboards and do all that. So all the AWS data sources are here. So you can see the Amazon Managed Service for Prometheus and all the data sources here. And we also support many other data sources too. So if you go to the data source section, click on add data source. There are lots of data source plugins that we deploy or install by default. You can see the list of data sources that we deploy here in this screen. So let's go to the AWS data source screen back again, and click on AWS services. And here I have Amazon Managed Service for Prometheus, which is what we want to query from. I'm going to select that, and when I select that, it's going to take me to the next screen. And here I'm going to select the US East one, which is where I have we have those Amazon Managed Service for Prometheus workspaces. Here you can see that this is the workspace that we created through the CloudFormation option, and this is the one that we created using the console. And the one that has metrics is this one, because this one we just created the workspace. We did not do any metrics ingestion into it. And I'm going to select that, click on add data source, and data source added. It says added, and go to settings. If you go to settings, you will see that this also uses the SIGV for authentication. It uses workspace IAM role. There are other options for you. You can also use credentials as well, but by default, just like the Amazon Managed Service or Prometheus, this Grafana also uses the Go SDK to authenticate into their data sources. So here I'm gonna name this to Observability Workshop, because that is the data source that we are talking to, and simply click on save and test, and data source is working, and we are good to go. So let's go and explore this data. So here I'm selecting this actually has the default data here, or the data source here. I'm going to select the Observability Workshop, and you can see that there is metric. The metric browser, when you see it blue, that means there is metrics here. So the workshop or the workspace actually has metrics. So it even has it has all the details, all the metrics that we collected from the AWS distro from OpenTelemetry Collector. If you remember, I talked about prefixing all the metrics with ADOT, and these are all the metrics from the service that are being scraped by the ADOT collector, and the ones that don't have the ADOT prefixes are the metrics that were collected by the Prometheus server. So you can select any of the metrics from here. Process CPU count, for example, simply just visualizing. Okay, maybe we can select a better one. Maybe something like this, contention seconds. So you can see that the metrics are visible from here. There is also other data sources that you can actually make use of. If we go to AWS data sources back again, you can see that there's CloudWatch, X-Ray, and all of the data sources. For example, for CloudWatch, you can again select we can select the region here, and then click on add data source, and the CloudWatch data source is added. If you go to settings, we actually have out of the box dashboards for CloudWatch. So you know that I was using EKS, and I told you that we had a couple of nodes, EC2 nodes. So you can click on import, so we can see the EC2 metrics as well from those nodes. And these are all the metrics. These metrics are from CloudWatch. This is not from Prometheus. These are from CloudWatch. So the Grafana is directly calling CloudWatch, making the CloudWatch API calls to fetch these metrics for us to visualize. All right. So now Grafana also allows you to automatically automate your dashboard creation process and all that. So let's go and see how you can automatically provision, create dashboards, and so on. Next, we're going to see how you can automatically create dashboards and data sources through APIs. So to do that, you need an API key. So to get the API key, you can go to settings, under configuration, click on API keys, and you can create a new one. So I'm going to delete what I already have. You can click on new API key and click on new API key. Name it new API key and call it, give the admin role for that. So anyone who uses the API key will be able to administrator actions. It's valid for 1 day, and clicking on add. So that's the key that got created. And I'm going to copy this, and I'm going to use a little utility called Insomnia. So Insomnia is a little tool that allows you to make API calls. There are numerous tools like this that you can use, but this is what I use. So here, I'm hitting the API/data sources endpoint on the Grafana workspace, and here in the header, all I have to do is basically go and replace the existing one with the barrier token that I just created, and it's a get call, so I'm going to send, and you can see that I have two data sources. One is the CloudWatch data source, another one is the Observability Workshop data source that we created earlier. So now what I'm going to do is I'm going to create a dashboard. So in the dashboard, it's a post method. You can see that this is the dashboard endpoint that you can send your JSON to. This is the dashboard JSON right here. And again, here I have to simply provide the barrier token that I created, and all I have to do is simply send this. So if I send this, there you go. So it created the dashboard, and the status is success. So basically that means that there is a dashboard called Pet Adoptions Dashboard that got created. So if we go to the Grafana page again and go to the home screen, dashboard home screen, and they manage here, so you can see that there is a dashboard that got created under this folder. So if I click on Pet Adoptions Dashboard, there you go. So it only has one panel. It's a pretty straightforward, simple panel, and that's the data from Amazon Managed Service for Prometheus.
All right. Hope you enjoyed the demo. Over to you, Mark.
Thank you, Maya. What a great demo. If Maya could do it, anybody else can do it. We have some resources that'll help you get this, going yourself. You can try it out yourself. It's super easy, as you can tell. Today, AWS is engaging with open source community in the following areas. It is important for us to continue to be thought leaders and good stewards of observability, open source, and open standards. We played an active role and plan to do so much more over the months to come in contributing back to open source for these projects. We are committed and continuing to contribute PRs, open new issues, and collaborate on design proposals with the open source community for open source projects that are key to our services such as Cortex, Prometheus, OpenTelemetry, and Grafana. Visit our customer page to learn more about how our open source fully managed services played a critical part in their observability journey, such as Twilio and Fanatics, and there's many more. We also have a list of advanced technology partners, security partners, and migration partners that can help you integrate and get started with Prometheus and Grafana. So please check out our site for more information there. Building observability requires reliable collection of data from metrics, logs, and traces. AWS is here to help you in your journey to support the open source tools you want to use to monitor and observe any workloads running anywhere. You no longer have to worry about securing these services and scaling to meet your needs. We are excited about these latest releases of Amazon Managed Service for Prometheus, Amazon Managed Grafana, and AWS Distro for OpenTelemetry. We look forward to hearing more about how we can simplify our observability needs, your observability needs, and ours as well, I guess. If you're just getting started or you want to learn more about our services, check out our service page, our blogs, documentation, demos, and labs. Most of what you've seen in the demo, you can do it yourself at your own pace and really take advantage of all these different services that we've talked about during this session today. Thank you so much.